السلام عليكم.
وعليكم السلام.
طيب بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. Let's start the lecture. Last thing I was talking about last time was this equation. What's this equation? What's the name of this equation? Hello?
بس دكتور
Yeah.
line spectrum.
No, what's the name of the equation? Who developed this equation? Who developed this equation? The name is very important. You must know. This is Bohr equation. Bohr equation. All right. And what does it say? What is this constant? What's this constant? What's the name of this constant? Don't memorize the number, but what's the name of the constant?
Planck constant.
Rydberg constant. Rydberg constant. Okay. What is n? What is n? Principal quantum number. We discussed this yesterday. You don't forget, don't remember anything? All right. Rydberg, as I said, don't memorize it. It's available in your book. But if you want it for energy, use this equation. If you want it for meter, then use this constant. Is there a relation between them? Yes. Actually, RH with lambda is same this RH of energy divided by H, which is Planck's constant, and C, which is speed of light. So whatever is available in your book, for example, usually we give you this in the periodic table. We'll give you this, which is related to energy. And when we ask you to do this equation, you do it for energy. And if you want to apply, if you want to know the wavelength, don't forget that E equal to hc over lambda. So if I want to know what is lambda, it's actually hc over E. Is this clear? You have to know these things, the relation. All right. Let's solve this problem. Calculate the wavelength in nanometer of a photon emitted when an electron transition from n equal to 4 to n equal to 2. Which one is the initial? Which one is the initial? Which one is the final?
2 final.
This is final and this is initial. Very good. What's the equation that we're going to use? Energy equal to what? RH.
Isn't 1 over lambda?
Well, both. As I said, it's possible. We can do it this way also. It depends. Look at your periodic table. I think you have only RH for energy. Do you have your periodic table with you? Okay, 1 over what? What should I write here? 2 square minus 1 over 4 square, close bracket. Go ahead and calculate RH. I think only RH, which is the one which is given to you, is actually 2.18. This is, as I said, from the periodic table. 2.18 times 10 to the power minus 18 joule. Okay, go ahead and calculate what's the energy. Are you with me, guys?
Yes.
Yes.
All right. Can you calculate the energy? Of course, there is a minus here. What's the energy? Hello?
Minus 4.09 times 10 to the power minus 19 joule.
Who got the same answer?
I got the same answer.
Okay, let's hope so. Minus 4.09 times 10 to the power minus 19 joule. But what's required here, wavelength. Wavelength. Can you calculate the wavelength? We know that energy is equal to h nu, or equal to what? h c over lambda. So if I want lambda equal to what?
HC over E.
HC over E. You have E here. This is H. And this is C. Go ahead and calculate what's lambda.
minus 4.86 times 10 to the power minus 7.
Lambda without minus. Minus is to say that it's exothermic or endothermic. But when we say lambda, it will be positive because it's a wavelength, it's a measurement. What's the answer?
4.86 or 87 times 10 to the power minus 7 meter.
So it is 4.87.
4.87. Yes.
Okay. Who got same answer? This is meter.
Yeah, the same answer.
Okay. What's the required measurement that we should have? Nanometer. Change it to nanometer.
So it will be 10 to the power minus 16 meter.
No.
Sorry, to the power 2.
Yes, or 487 nanometer. Excellent. 487 nanometer. And the correct answer is 1 over this number. So I hope it's the same. Yes, it's the correct answer. So lambda even here is equal to 487. Good. All right, let's move now. Next, I'm going to explain something new. I want you to know what's known as de Broglie equation. De Broglie equation. Important name you must memorize, like Bohr. And now de Broglie. De Broglie is the name of the scientist. De Broglie. What's de Broglie? De Broglie talk about waves, and he talk about first nodes. Nodes is where the value of the wave is, or the amplitude, not the value, but amplitude, or value of the wave is 0. What do you mean by this? Like, for example, we have one node here. We have two nodes here. Nodes. We have one node here and two nodes here. So there is 0 node in this one node, and 2 nodes. Clear? All right. Okay. Anyway, I'm not going to explain things much for you. Actually, he looks at the wave like the guitar, and then look in these things. You don't have to know this. The most important thing that I want you to know in de Broglie, that if we have a circle, like this, the waves in the circle must be continuous. This means it has to be full wave, not full wave. For example, in this thing that I'm drawing here, this is 3 waves, and they have to be continuous like this one. N is equal to 3, N equal to 5. Here, N equal to 3 and 1/4. This is not acceptable, it's forbidden, but this is acceptable and this is acceptable. What is he trying to say? That 2 by R, what's 2 by R?
The perimeter of the circle.
Exactly, circumference. Circumference of the meter, this means this circle, is equal to N This means n must be whole number times lambda. So we have 1 or 2 or 3 lambdas or 4 lambdas. This means the circumference 2 by r must be, the wavelength lambda must be multiplied by n, or n quantum number. This is one way to look at de Broglie equation. De Broglie equation. The circumference 2 by r is the circumference of the circle, must be a number which is n multiplied by lambda. And n here is the same principal quantum number that we are talking about. Clear? Which is 1, 2, 3, 4. This is, as I said, what's the name of the scientist?
De Broglie.
De Broglie hypothesis. Hypothesis means assumption. De Broglie. Don't forget the name of the scientist, de Broglie. What's the equation? It's very simple. 2 by r equal to n lambda. The circumference must be equal to n times lambda. We know 2 by r. What's 2 by r? Is the circumference. What's lambda?
The wavelength.
Wavelength. And what's n?
Number of nodes.
Number of nodes. No, not number of nodes. Number of waves. Number of waves. Not nodes. All right? And number of nodes, this, which is actually, we got it before. What is it? Principal quantum number. Did you get it? It's the principal quantum number, which we gave 1, 2, 3 for hydrogen. Okay, there is very important equation. N is an integer. This means, what's the meaning of integer?
No fraction.
Yes. Any number of these. It could be 1, 2, 3, 4, 5, 6, 7, 8, and you can continue. All right? Okay. And because the energy of electron depends on the size of the orbit, the energy can now have only certain values too. Because of energy, electrons, hydrogen is constant. As I said, the most important thing is to know when we have to write de Broglie equation. What is it? Tell me what's the equation now. It's de Broglie again. What's the equation?
2 by r equal n lambda.
R equal to n lambda. And you should know everything. 2 by r, what's 2 by r? One more time.
Circumference.
Circumference of the circle. المحيط. Circumference. المحيط. All right. And what's lambda?
Wavelength.
Wavelength. And what's n? Integer starting from 1, 2, 3, 4, 5, 6, 7, whatever integer you want. Is this clear? Good. Now, de Broglie also have another extremely important equation in which I want you to memorize extremely very, very well. This equation. Lambda, I will write it here one more time. Lambda. What's lambda?
Wavelength.
What's h? What's h? Hello?
Rydberg constant.
I know. Planck's constant, not Rydberg, Planck's. All right. And what is M?
The mass.
Mass. And what's U?
Velocity.
Velocity. Fantastic. Super. Okay. I want you also to memorize this equation extremely well. What's the name of this equation? De Broglie again. De Broglie. Both equations are de Broglie equations. All right. What's interesting about this equation, if you have an electron that it will have mass, right, and speed. The mass is m and the speed is u. Okay, if you have an electron and it is a particle, then it will have a mass and certain speed. You can change this mass and speed into wave. This means you can, okay, the electron could be could be particle or wave. And we call both of these things dual function. This one and this one, we say dual function. Dual means two. Okay, what's this equation? Look carefully at this equation one more time. It's very important. Look carefully at this equation. This equation says that the electron, which can have mass and wave, I can change the mass with the speed into wave. This means I can change anything from mass to wave. This means I can take any one of you and change him from a person to a wave by this theory. Is this clear? Okay, that is.
Doctor,
Yes.
it is reality for that.
Of course, they think this is a reality for only small things like electron. But according to this equation, if you are moving at a certain speed, I have your mass, and I have your speed. I can calculate your wavelength, so I can change you from mass to wave. Is this clear?
Yes.
Yes, that's exactly what I can do. And in this way, we call the changing, and this is applicable for electron. That's why we came up with this equation, and we call being particle or wave, yeah, this means mass or wave, we call it dual function. What's dual means? Two functions. All right, let me okay, I will take the attendance now. Be ready, and I will send you the Okay, let's have attendance. 1 minute. Are you done?
دكتور
نعم.
هو نفس الرابط اللي رسلته الكلاس الماضي صحيح؟
صح. يلا يا شباب بسرعة.
دكتور
نعم.
هل في احتمال في تغيير اللي هو توزيع درجة التست الجاي مع الفاينل؟
ما تكلمنا عن الموضوع لسه ولا شيء. لا ما في، ما اعتقد، ولكن ما تكلمنا، ما سوينا شيء. زي ما قلنا ما تكلمنا عن اي شيء عن الاختبار لان لسه النتائج ما جات.
لا دكتور أتكلم على الاختبار الجاي اللي هو تست مع الفاينل.
لا 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 في تست ان شاء الله. خلاص يا شباب. All right, let's continue our discussion. All right. So I want you to memorize this equation extremely well. What's the name of the equation?
liberal equation.
Pauli equation. What does it do? Change what?
Change particle from
Change mass to wavelength.
Yeah.
Wavelength or waves. Change mass into waves. This means, as I said, I can change you from a person to a wave. Okay, very good. Let's solve this problem. Calculate the de Broglie wavelength for a particle with the following. Let's do it for this one, which is electron. For an electron with this mass moving at this speed. Okay, what will be lambda for this electron? Go ahead, quickly. Don't forget that you need H. Lambda equal to what? Very quickly.
2 by R over N.
No. Lambda equal to H over mu. Okay, you have H, this is H. This is the mass. And this is the speed. Calculate lambda.
دكتور 0.1 multiply by 10 to the power minus 6.
0.1.
1.1 multiply by 10 to the power minus 6.
10 to the power minus
6.
no 5.
Yes, fine.
1.16 times 10 to the power minus 5. That's all what you need to do. Then you have the mass, you have the speed, and you have H. All right, I hope so. Okay, also in another experiment, there was diffraction of electrons. This means we hit something with beam of electrons. We hit this foil with beam of electrons, and we saw from the electrons this shape. This is light. We hit this thing with electrons, and we have this shape. This is called diffraction of electrons. This means the electrons are actually showing us light, or it looks like waves. So the electron could be wave. very important theory that I want you to know. Memorize the name of the theory and the name of the scientist. This theory is called uncertainty principle. Uncertainty principle. Heisenberg uncertainty principle. Heisenberg uncertainty principle. Okay, as I said, I want you to memorize this name and the name of the scientist, which is Heisenberg. Heisenberg uncertainty principle. What does it say? That the error in x, which is distance, distance, times the error of momentum. What's p momentum? What's momentum? The momentum equal to what?
mv
MV
Times u, exactly. Mass times u. That's momentum, and this is mass, and this is speed, and this is momentum. All right, so the error in distance times the error in momentum, or mass times speed, is greater than or equal to x, h. What's h?
Planck constant.
Planck constant. Divide by 4 pi. What's pi? Right? What's pi?
3.14
3.12, isn't it?
yeah.
Later, I forgot what is it. 3.14,
3.14.
huh?
Yes.
3.141, yes. 3.4, this is from the calculator, 3.141. So remember this equation. We will solve a problem right now. Okay? Okay. An electron in hydrogen atom is known to have a velocity of, this is the velocity of the electron, and the error is 1%. So what's delta x?
Minus and plus 1.
Sorry. Velocity. Why I say x? Sorry, just a second. Okay, it has a velocity of this speed. So what's delta u? Because we know that p, just a second, let me say this. P equal to mass times u. The error in p is equal to the error in mass delta p. Can we write now Heisenberg equation one more time? Delta x times what? Mass delta u greater than or equal to what? H over 4 pi. That's Heisenberg equation. Are you following?
Yes.
Okay. What's the error in speed? What is it equal to?
1.
No, it's here. It's the velocity times the error, times 1%. Okay, so delta u is equal to 5 times 10 to the power 6 times, what's the error in it? 0.
1 over 100.
1%, or we can say that the error is 1 over 100, because it says 1% the error. So we can calculate delta u. It's 5, which is the speed, 5 times 10 to the power 6 times 1 over 100, which is the error, and this will give us the whole error in X. If the mass of the electron is 9.11 times 10 to the power minus 31, then what is delta X? So we know delta U, get the answer for this one. Now multiply M delta U, which is whatever answer you have here, multiplied by this mass. And then calculate delta X, which is equal to what? H over 4 pi divide by, or we can say that this is equal to M delta U. Then calculate delta X. I want you to do it quickly. You have H as usual. This is H. Divide by 4 pi. By the way, what's the answer here? Five times 10 to the power what? Come on. 4.
10 to the power 4.
Exactly. All right. So we know this now. We know what's H, what's delta X.
Uh, 1.05 times 10 to the power minus 39.
I got the same answer, doctor.
Minus 39?
Yes.
Yes. Because of
Minus,
time constant and
okay.
delta.
Delta X equal to, could be, it's wrong. Something wrong. Something. Did you divide? Maybe, no. Did you divide it by M delta U?
Yes.
So what's the answer?
It is 1.05 times 10 to the power minus 39.
هذا أنت مقسم 10 to the power minus 31 divided by 10 to the power minus 34. It cannot be that value. It cannot be.
Doctor, it is 1.05 multiplied by 10 to the power minus 35.
Yes.
بس في
No,
4
39.
باي في المقام.
Doctor, yes, 39.
بحسبها بسرعة. 9.11 exponential 31. I have it 1.5 times 10 to the power minus 6. How do you have it that way?
Maybe you didn't multiply delta U by the mass of the electron.
I did.
Maybe we didn't.
Yeah, you did not divide by the mass of the electron.
Doctor,
I made a mistake. Just a second.
Yes, the problem we saw that m delta u equal 5 times 10 to the power 4.
Doctor, in the answer we didn't multiply because m delta u is not equal to 5 multiplied by 10 to the power 4 because we didn't multiply by the mass.
Yes, I got it 1.15 times 10 to the power. When I did the calculation, I got it 1.1 times 10 to the power minus 9 meter, or 1.1 nanometer.
Yes.
If you calculate it correct, that's what you should have. Okay, and actually, this is the right answer. It is 1 times 10 to the power minus 9. Okay, and in here, the error, the nucleus of the nucleus of the the atom of hydrogen, the hydrogen here is the error. The distance from here to one here is 1 angstrom. In hydrogen atom, we know that hydrogen atom, the distance from nucleus to the electron is 1 angstrom. You know what's angstrom? Did you ever see what's angstrom? When we write A with a circle, this is called angstrom. Angstrom, and it's actually 10 to the power minus 10 meter. All right? And you can see that we know that the I forgot it. نصف القطر للهيدروجين is 1 angstrom, and the error is 10 angstrom. So you can see here the error is so big in measurement when we go to these things. So the error here is 1 angstrom, but this is the real hydrogen atom. نصف القطر is 1 angstrom, but the error in measurement is 10 angstrom. 10 angstrom, which is a lot. And that's why the uncertainty in electron position is 10 times bigger than the atom itself. So we have big error in doing all measurement when we go with this equation. That's what uncertainty principle is, to measure the error in these measurements. Okay, the last thing we'll talk about today before we leave is actually another equation, very important equation, which is called Schrödinger equation. Schrödinger equation. And Schrödinger equation, I don't want you to know anything about it other than this symbol. This is the whole equation. We use this symbol like this to represent it, and this is actually called, we should write it like this, but when we read it, we just say psi, as if there is no P. So psi What is psi? Psi is called Schrödinger, another scientist name you must memorize, Schrödinger equation. Schrödinger equation, which is psi, which is this thing to represent the wave, to represent the electron wave, electron waves. Can you see here? Psi, or it's electron wave, electron function. Psi is electron function. It's a wave function to represent the electron. A wave function to represent the electron. What do I mean? For example, if I tell you we have this wave, what's this wave? Do we know what's this wave? This is y equal to what?
Sine x.
Sine x. So this wave function represents this wave. Clear? This wave function represents what? The electron. It's a wave for the electron. It's a wave function for electron. You see that this wave represents, or this wave function, y equal to sine x, represent this wave. But this wave, which is psi, represent what? The electron. That's why we call it wave function. Wave function. All right? Then we have also psi square, which is same psi square. This is probability. Probability. So this is probability of finding electron. Okay, so what's psi alone? What's psi? Only a psi. What is it?
Function, wave function.
Wave
electron.
function to represent what?
The electron wave.
Represent electron. Exactly, the electron wave. Exactly. Wave, very good. Is this clear? What's psi square?
Wave probability.
Probability of finding the electron. Probability. What do you mean by probability?
احتمالية.
احتمالية وجود الإلكترون. So I want you to know these two functions, psi and psi squared. And you know what's each one. You have to know it extremely well. Is this clear? Okay, with psi and psi squared, they start looking at the electron and they found that the electron is a wave, and this is how the electron is available around the nucleus. This is the nucleus now. This is the nucleus. Where is the electron? Called this light.
Around.
Light. The electron is electron light, and that's why we talk about electron density. Electron density. You know, if the electron is a mass, if this is the nucleus, then where is the electron? The electron is something like this. That is if it is mass. But if it's a wave, where is, if this is the nucleus, where is the electron? Where is the electron if it's a wave?
Around it.
Around it.
It's light actually around it. It's light. You can consider this is light around the nucleus. It's exactly like when you put the light on your room on, where the light goes? In the room. Clear? That's where the electron, so this is Can you see this is 1 electron or maybe 2 electrons? It depends. All right? It could be 1, 2 electrons or even more. We don't know. So the electrons are like light now. And if you have a room and you have 1 bulb in the room, when you put the light on, where the light is going to go in the room? All over the room, right? لو هذه غرفة غرفة وعندنا إضاءة من هذا النور، اللايت وين حيروح؟ في الغرفة، صح؟ صح؟
صح.
طيب لو حطينا لايت ثاني، لايت بلب ثاني، وين النور بيروح؟ برضه في الغرفة. ايش الفرق بين غرفة فيها 1 لايت عند غرفة فيها 2 لايت؟
الاستضاءة فيه موجات بناءة.
The light density. How much density? وين اللي higher density? This one or this one?
اللي فيه لمبتين.
Density higher, and that's why you have same thing now with the electron. You can think about the electron. This is the nucleus. If there is 1 electron, it will have certain light inside this circle. If this is the light, the dot here. If I put 2 electrons, what will happen to this light? It will be the same light, but it will be what?
More dense.
More dense. That's it. This will take us to 5.6, 6.6. I will stop here. All right.
صار عندي سؤال.
يلا خذ راحتك.
من حين الإكس في ساين إكس وش تمثل؟
إكس في ساين إكس.
الآن عندي هذا حق شو اسمه شرودنجر، المعادل اللي واي يكوال ساين إكس.
واي يكوال ساين
وش تمثل الإكس يعني؟
زاوية أرقام معينة. هذا رياضيات الآن، ولكن واي تساوي ساين إكس. إكس هي الزاوية، هي زاوية معينة، قصدي ايش يسمونه الزاوية.
أذكر في يوم أخذته في فيزيكس مكتوب أوميجا تي، هل هنا نفس الشيء؟
ايش قال مكتوب؟
أوميجا تي. أنا في الفيزياء ما أدري عن
أوميجا تي.
إيه الفريكونسي الظاهر ما أدري.
إيه الفريكونسي أوميجا.
ناسي والله. I don't know what you're talking about. ولكن هذه الإكس هي عبارة، أنا جبت هذه كمثال إنه الويف هذه لها ويف فانكشن. الآن احنا ما ابغاكم تعرفون معلومات كثيرة، ولكن الإلكترون له ويف فانكشن. That's all.
دكتور.
نعم.
يقصد ان الساين اللي هو الويفز راح تكون with respect to angular velocity which is sin omega minus t.
هذه قانون لحركة معينة. لا هذا احنا الآن نتكلم عن ساين اكس. هنا ساين الاكس عبارة عن زاوية، زوايا يعني 45 الانجلز.
نعم.
انجلز، والواي رقم معين، وهذا الويف represent this angle y equal to sin x exactly. And I just want to tell you that psi لا تحفظونها إلا psi بس، اللي عبارة عن wave زي هذا الويف function تمثل electron. So it's electron wave function. All what I want you to know is that psi is electron wave function. That's it.